So I'm David Chelimsky. I work at Cognitect, but you already knew that because of my striped shirt. I've been there for about 5 years, and I used to work in this other programming language that some of you know. And then I was hired to come to Cognitect and be like the one person who still writes in that language, and then they made me do this parenthetical thing, and here we are. So some of you maybe work on programs that have to interact with AWS. Raise your hand if you've had to do this. Clojure programs specifically, right? So most of you, right? And so what are our options if we're doing that? We've got the AWS SDK and Java, right? And this is a great thing to have. All the Java community uses it. It's been around for a long time. It's completely reliable. It's comprehensive. But it's object-oriented, and that means it's got all the things that object-oriented brings to the table. It's got class hierarchies that we don't really care about or want to know about. You have factories to make things. JavaDoc, which leads to this development style called Google-driven development. Tons and tons of entry points. And you end up with like these data classes for every request that you're going to make, every different kind of request, and the response as well. And so there's a lot to learn about. And so here's one example of these data classes. This is as simple as you can get. This is just asking for an object from S3. And you start off by making a get object request, and it takes 2 arguments. There's one that's a string, and there's another one that's a string. Now, you know, who knows what these things are? You could go look at the documentation, but there's nothing intuitive. Well, you can make an educated guess that one of them is going to be the key, one of them is going to be the bucket. You could probably guess the order, but you're guessing, so you have to go look at the doc. And there's a reason that it's structured this way. It's because a get object request requires these 2 fields, the bucket and the key, and it's invalid unless it has those. So that's how we do things in Java, is you put all those things on the constructor, and then you add other methods, setter methods, to set the other things that are optional. So what we really want is something that looks like that, right? A map, right? Rich was talking about this yesterday. The map, it's got all the keys. You know what they mean because they have names that you can understand. And you can look at that data and you know exactly what it is. So it turns out that there are 164 different Amazon services. And there's an average of this many, a little over 31 operations per service. There's more than 5,000 operations that you could do. So I don't know if this is actually true because I don't know that you have returns for every one, but somewhere in the region of 10,000 data classes. And by the way, I know these numbers not because I went mining the Java SDK, but we'll come back to that a little bit later. All right, so what are our other alternatives? We have wrappers like Amazonica. And you know, that's great. Like wrappers serve a purpose. It feels like Clojure, it looks like the rest of our application, but it's still just wrapping the Java SDK. So under the hood, we've got all the things that I just talked about. And it makes it more accessible because you could write these things in Clojure. But on the other hand, understanding like what the requirements are of each one is not a simple task. You've got to go searching around to find it. It's all based on reflection, some of which happens at runtime. Like most of it happens when you start up. But I think some of it happens too when you make calls. And again, we've got this JavaDoc Google-driven development problem. And there's also limited discoverability. You have to, the same thing about using the JavaDoc to understand how to use things. Just to understand what's there, you've got to go find JavaDoc. And of course, these things are in like these class hierarchies, so you got to look at 5 different JavaDocs to find out how to do one thing. All right, so we also have some pure Clojure alternatives. There's actually one that I know of. But it's, you know, it's got all the things we want. It's data-driven. It looks like Clojure. It's got generated Clojure spec, right? This is a great thing because it generates the Clojure spec, and you can, from these service descriptions that I'll talk about a little bit later. And even if you get the arguments wrong, you get feedback from the Clojure spec output, and it can help you along without having to go searching the internet to find out how to do things. It also supports async. It does it through binding instead of making it a different function or an argument to a function. But unfortunately, for this particular library that I'm thinking of only has a small subset of all the APIs supported, and they're all in one artifact. So if you want to use any one of them, you have to depend on all of them. Okay, so what do we want? Well, we want something, obviously, that's idiomatic closure. We want something that's data-oriented. And when I say data-oriented, I'm not just talking about like map in, map out, and we'll talk more about that. We want async available as like a primary thing. We don't want to have to do bindings or whatever, just make it a function argument. We want discoverability at the REPL, and we want docs in the REPL. The other thing is we want direct communication with AWS. We don't want to have to go through all these layers and layers of stuff. It's just we've got some data. We want to make an HTTP request using that data. We want to send it off and get back data and show it, right? We also want pay-as-you-go. We don't want to have to depend on the things that we're not going to use. So we want to be able to depend on only the services that we're going to be using in our application. We want a separate artifact for each different service, and we want to only load the stuff at runtime that you need. So when you've got things like documentation and Clojure specs, we don't need those running in our Lambdas. We need them when we're at the REPL and we're making things. So it turns out that the other SDKs are a little bit more data-oriented than our Java SDK. And so for the JavaScript SDK, which has data that looks like data, and same thing with Ruby, a little kind of with Go, but all three of these have these service descriptions. And if you go look at these directories on GitHub, you'll see something that looks like this. And you can see this is a listing of some files. These are all JSON files, and they all have a bunch of information in them. So let's go look at one of them for a service. So this is just a snippet. At the beginning of each of these data descriptions, you get some metadata about the service. You see what its name is. You see there's an endpoint prefix. I don't know why that. Oh, I see. I was wondering why endpoint prefix is blue, and it's because I forgot the comma on the line before. So anyway, there's something about a protocol, a signature version, so something about signing requests and whatnot. And then there's this API version, 2006-0301. Now, in this file, if you look at the history of the file, you'll see that there have been hundreds and hundreds of changes since March 1st of 2006. So we can hope that these have all been additive changes, and they didn't break anybody in the process, and we'll just go with that faith. But this has been the API that's been in place in some form or another since back then. Anyway, if you look further down, you'll see a collection of operations, right? And the operations, so here's one to get an object from S3, right? And it's got a name, and you could see it's a GET request, and you format the URI this way. And then there's this thing input, and input has a shape. And the shape of this input is GET object request. I'll come back to that in a second. You can see further down there's some documentation. You could see some HTML tags there, so you know that this is intended for presentation on the web. And this is actually the documentation you'll see if you go up to the Amazon documentation. And yeah, you'll see retrieves objects from Amazon S3 without the p tags. All right, so here's what a GET object request looks like. And this is only a small subset of it, but you can see it says that it's a type of structure. So each of these shapes have some kind of type, and there are three collection types and a bunch of scalar types. But here's where it starts to get interesting. If you look at the members, the first one is called bucket. It's got a shape, another shape, so we have to go look somewhere else to see what that shape is. But probably if we went and looked there, it would be a string. I can almost assure you that that's the case. Here's the interesting bit. It says location URI. Now that's kind of cool. So this is basically saying, okay, we're going to take some data, and this particular field, we're going to go stick it in the URI. If modified since, well, this is this one goes in the header, right? And then the object key goes in the URI. So you could see what's going on here. We're getting these recipes for building HTTP requests, and we have a recipe for getting the response and turning that back into some kind of data to hand off to your program. And this is like gold. This is what we want, right? Because it's completely mechanical, or at least it has the promise to be, right? We've got all these service descriptions. There's 100 and whatever I said, 60 something of them. So we decided to make a thing. We started this project back in 2015, and as Alex alluded, it's had a cast of characters coming and going. These are all the people who either have commits in the repository or have been very involved in the design. I can imagine you might guess which one of these people does not have commits in the repository but was very involved in the design. This is so. Some of you know, or some of you don't. Like at Cognitech, on Fridays we have the magical 20% Friday where we do work on projects for like internal things, and that's where all this work got done, was on Fridays over the last 3 years, and certainly not every Friday. And yeah, I'm involved with this, but like I did a lot of the work recently just to sort of package things up and get it going. But there's a lot of people here who did a lot of thinking and a lot of work, so everybody here deserves a lot of credit. Okay, so this is kind of what it looks like. So all the way on the left, you see we've got this endpoints descriptor, which is a JSON file that we get that just says these are all the endpoints for all the different services. And then we have n service descriptors. And we have this generator that reads those things in and makes smaller versions of them and generates some Clojure specs. We're doing that too. We wrote a library. What you depend on, you have to depend on 3 things. You have to depend on the API library, which has all the Clojure code in it. You have to depend on this endpoints library that has the descriptions of where things are. And then you have to depend on one or more of these little service artifacts per service. So, and just a little more detail here. So the API, which by the way, it's about 30K is the size of the jar, compared to 900 something for the core AWS Java SDK library. And then, so your app is going to depend on these 3 things, but the only thing you're actually using is the API when you're running in production. You might use directly from your app some stuff that's in the service because we're going to use Clojure spec at times, and you might want to go after things that are in there directly or go and look at that yourself. But for the most part, you're just using from your application the API, and it uses the other things. So they all have to be there. And you know, we pre-decomplected all these things for you. Maybe it offends you that there's data and specs in the last one, but you know, they actually belong together. They represent the same things. So all told, to like the smallest one, and I'm sorry, but I don't remember which one is only 4.3K, but we're somewhere in the range of what, 30, 40K, up to maybe around 200K for the most expensive one. That one I know is EC2. Anyway, these are small things, and that's nice. So here's how you use it. You depend on these 3 things. And by the way, look at these version numbers. Like the API is brand new. It's still 0. Then there's the endpoints. Well, it's 1 point something. It's pretty mature, right? But The S3 has been around for like 1,000 years. Version 661. All right, so let me explain what these things mean. We don't need to get into too much detail, but just so you have some idea. So remember that we're generating things from existing repositories, and we're not storing that anywhere. We're just putting it in jars and shipping them. So for the endpoints, we get that from somewhere. It happens to be the Java SDK, because that's one place where that file lives. And this is the first place that we're getting it from. Someday in the future, we might try to get it from a different place, or we might decide to get it from a different place, at which point that one will become a 2, and you'll be able to go to the GitHub repo for the API, and you'll see what these numbers mean. So the version in the source repository is 1.11.457, so the version of our jar is it's got that 1 for that's our source ID, and then the version from the AWS repo. And this way, if you ever need to understand, like, where's this stuff coming from, like, you have a way to map this to things that are all available up on GitHub. For the services, we have a generator that's generating the Clojure spec, and it does very little manipulation of the service files. It just kind of trims it down so that we only take out the bits that we need. And our revision of that is 661. And so that's what prefixes this version. The 363 is the version of the AWS SDK JavaScript, which is where we're getting all the services from. All right. So here's how you use it. You require this namespace, client API, and then you make a client. And to make a client, you give it a map. And the map says that the API is S3 in this case. And if we want to add other stuff, we'll add it to this map. So this will always stay nice and clean like this. That's never going to change. It has no need to. To use it, you call invoke, giving it the client, and you tell it the operation. Now, some operations need some data, and we'll get to that, but this particular list buckets operation doesn't need any additional data, so that's all you need. And that's the whole thing. This is the whole API in terms of what you need to run in production. There are some helpers and stuff I'll talk about, but that's it. So thanks very much. All right. So we also have some tools that you can use in the REPL. So there's this ops function, and that will give you a map of the names of all the operations bound to some data about how to use those operations, and we'll be looking at some of that later. If you want to see that printed out the same way you use the REPL doc function, there's an API doc function, and it gives you very similar output, and we'll look at that in a minute too. And then the other thing you can do is you can say, I want to validate all the requests I'm making. This is something that you would only do at development time. And it loads up Clojure spec and all the specs for the service that you're working with, and then it validates the request for you. So let's look at how some of these things look. So if we call doc on getObject, we get that, and I realize that's very small, but that's like the whole printout, and I'll zoom in on part of it. So you could see this is familiar format, right? You've got the name of the thing, here's the documentation with the pretty HTML tags, and then this is what a request looks like. And you can see down at the bottom it says that what's required is the bucket and the key, right? But there's a bunch of other things, and you can see what types they all are. There's a string, there's a timestamp. We don't care here, by the way, about where these things go in the HTTP request, right? So that's really nice. We just have a little map. We're going to pass that in. It's all really easy to understand. And this is what the request ends up looking like for this. So in addition to the op key, we add a request key, and then you put the map of data which you built up because you knew what that all looked like. You can do this all in the REPL. You don't have to go anywhere to find this out. Now, there's other information that you're going to have to go searching for, like what does bucket mean? Like, we don't actually have that here. We have access to some of that, and we'll probably add it later on, but it's not really consistent, and so we have to figure out how we're going to do that. in any case, this gives you a lot, though, right at the REPL. So if you turn on validation, validate requests true, you could see I made a request here and I'm missing something, and you get this output from Clojure spec. And for those of you who've used this should be really familiar. For those who are new to it, you could see the keys in the top of the map are problems, and it's a collection of the problems that were encountered, and then the spec, and this is the name of the spec, or the key of the spec that was invoked. And this is really helpful when you're dealing with a deeply nested structure. It's got the values, so you could see that the specific part of the request that created a problem was the map that's bound to the key request in the call. So you can get right to wherever the problem is and try to figure out what's going on. Pay as you go. So the first time that you call doc, or the ops function, that's when all the documentation gets read into memory. It's not there until you do that. And then same deal with validate requests. That's when all your specs get loaded up, and even the Clojure spec namespaces are not required until you do this. So they're nowhere to be found. All right. So responses. So we hand a map off to our API, and it makes an HTTP request, goes up to AWS, and gets a response back. And so the response map that we're going to deliver back to you doesn't really have all the details of the HTTP request, and sometimes you want to be able to see that because something went wrong in some way or another. So we put that up in the metadata on every request, whether it's successful or a failure. And so you can imagine, here's a call to list buckets, and that succeeded, and it came back with some data, and I can use that data. But in this other, and then you go look at the metadata, and there's the HTTP request. We could see we got a 200, there's a bunch of headers, and you can see the body. The body, we get it, we're using the Cognitect HTTP client library, which is the same thing that is used by the Datomic client. It delivers to us a byte buffer, so we turn that into a string. So you don't have to worry about that looking at this, but otherwise we're not doing any kind of transformation. This is just what's in the response that we get back. So then here's what it looks like if you get an error. It looks exactly the same. I asked for a bucket that doesn't exist. Amazon sent back data that says, hey, this is an error. There's no such bucket. And we've also, you could see at the last key there is Cognitect anomalies category. It's incorrect. And actually, that is true. I'm not going to go into the details of this right now, but it's not 100% consistent what kinds of things we end up getting back. Amazon sometimes gives you 404s when things are missing, and sometimes it gives you different kinds of numbers. And anyway, we're doing our best to just relay what's there. But you could see now in the HTTP response in the metadata, okay, you can see that what we got was a 404. And this is actually a great example of why this is useful, right? Because you can understand what Amazon was actually sending us back. All right. So in these data description files, the JSON files that I talked about at the beginning, there are some number of types that are described. So this is just a table of the types as they're named by Amazon and as we are interacting with in our Clojure application. So if a thing is a string, we're going to expect a string. If a thing is a long or an integer, we're going to expect a long. And that's what we'll deliver back to you. The only one where those two things aren't the same is a blob. So we'll accept either a byte array or an input stream. And we're going to give you back an input stream when it's a blob on the response. Just to full disclosure, or at least partially full disclosure, we're not streaming at this point, right? So we probably will at some point. I can't guarantee it, but the client we're using doesn't do any streaming, and so we're not streaming. At the point that we do, you won't have to change a thing. You'll just be able to use files that are bigger than memory all of a sudden. huzzah. But for now, it has to fit in memory. I think that's all the interesting bits there. So what I've shown you so far is like sort of the minimal that you need to just do stuff. But there's quite a bit more going on under the hood, and there are things that you have some control over. So I'm going to talk about a few of those. Just checking the time. So back off and retry. So I think it was during Stu's talk yesterday where he said, oh, look, that was back off and retry working. So for anybody that's news for, the idea is a request comes back, or it doesn't come back, or we get some kind of error, and we want to decide whether we want to retry the request or not. So we have this retryable predicate that takes the response. If it is not retryable, we're going to just give you back the response. If it is retryable, whatever that means, and we'll talk about that in a second, then we call this backoff function, and that's going to give us one of two things. It's either going to give us nil, which is a signal that we're not going to retry, and we just give you back the response. If it gives us some positive integer, we're going to wait that number of milliseconds and then retry. And then we get the response, and the whole thing happens again. So the default implementation of this, okay. The default implementation of this returns true if we get back this anomaly category busy, which means you're being throttled, or if it's unavailable. And you can also, this is the retryable predicate. So this is like, if either of these things are true, then we're going to say, yes, this is a retryable request, and if not, we're just going to hand you back the response. If you want to override that, you can hand your own retryable predicate to either the client when you're building the client, or you could do it on a case-by-case basis on an invoke. You're probably never going to need this, but it's there if you do. Same deal with backoff. We've got a default backoff. It's a capped exponential backoff. It starts at 100 milliseconds, max 3 tries. And if you want to provide your own, you can do it when you're building the client, or when you're, I said building the client, and there's that one little line of code that strikes me as funny. But anyway, and then when you're invoking one of the operations. So there's another thing that happens under the hood, which is credentials, right? You got to be able to be identified and to be able to use all these services. So we've based our default credential provider on the one in the Java SDK. So if you're in a world where you're using the Java SDK or using a wrapper for the Java SDK and you have all these environment variables set up so it all works, you won't have to change any of that. You can go read this page for more detail, but basically, first it looks to see if these environment variables are there. If they're not there, it looks at your system properties. If there's nothing there, it looks at your credentials file, and you have an opportunity here to say, well, instead of using the default credentials file, which is in your home directory, use this credentials file. Or you could say, once you get the file, or you can say, once you get the file, instead of using the default profile, you can use this particular profile for this case. And you do that all without touching any code. That's through environment variables. Then there's also 2 other providers that happen when running in AWS, and you don't have to worry about those. They're magic. And then we have a similar thing for the region providers. So you got to know which region you're running in or trying to access. And it's all pretty much the same stuff. This is all in the documentation on the well, actually it's not, but it will be very soon. So you can read more about that later. So to customize these, you can give it a custom credentials provider. This is really handy mostly when you're doing testing. You hand it a credentials provider that has a specific set of credentials so that you could do things. Same with the region. I doubt you'll actually ever need that running in production, but who knows. All right. The other thing is that we've got async at the function level instead of having to sneak things in through the side door. So the way you do that is you require this other namespace. And then instead of calling AWS invoke, you call AWS async invoke, and it gives you back a channel. And then you could do whatever you do with channels. And you can also provide it your own channel. So in this example, I'm handing a promise channel with this transducer that's gonna take the table. You know what? I didn't test this. Those are backwards. So it's going to take. It's first going to take the table out of the top level map, go into that, and get the table status and return that. And so we're calling the describe table function. And you might use this to retry this a bunch of times yourself until it says that it exists. Or I forget the word you're looking for, but there's a word that says it's, you know, the table exists, and now you can move on with your program. All right, demo. Whose idea was that? Excuse me, just 1 second. So yesterday you all met the rebel. Oh, I don't know if I can. I don't know that I can resize it. Is it going to be big enough for you to see something? Hey, why don't you all in the back just like move up front? You'll be able to see it just fine. All right, so here I'm requiring the API namespace. And look at that, it worked. And yeah, there's nothing to look at there after, because require returns nil. And now I'm going to make I'll make a DynamoDB client. So AWS client, and remember you just tell it the API and cannot find resource. Uh-oh, I didn't load this up correctly. All right, talk amongst yourselves for just a second. And there'll be fun. I did do it correctly. This may end up being a good time for questions. I actually don't think that's the answer, but it sounded good. Let's see. Now, you see, I had typed this before so that I wouldn't have to type it now. Oh, come on. Wow, is everybody having fun?
You use the AWS Snowball API to get like a truck delivered with like a local AWS cluster, so you don't.
We'll be able to do that with Rebel. You datafy the thing and a truck shows up. It's awesome. I could not be joined. So that means I'm not going to be able to do anything on AWS, so this is not going to be that much of a demo. So I've actually only got about 5 minutes left, so I'm just going to go back to the slides. I apologize for that. You saw how awesome Rebel is. I could tell you about a couple of things. All of the data that you get in the REPL, instead of having to call extra functions, you could just start navigating through all the documentation. And remember those beautiful HTML tags that look terrible when you're just printing them out? Well, Rebel's going to show you that as HTML, and you could slide over and click on different tags and go look at the documentation right there in Rebel from the web. I got to shut this down now. All right. So this is alpha. We're just releasing it now. You'll be able to use it today. I'd go look on the internet to see if somebody opened up the the repo, but I can't. This is designed for dealing with services. right? This is not an SDK. It doesn't have a ton of helpers to do things that you already know how to do in your application. So for example, we're dealing in input streams. We're not going to accept a file. You can turn a file into an input stream and give it to us. You all know how to do that. And if you don't, Google-driven development. It works. You know, there's 160 odd services, and no, I haven't tried every single one of them. We don't have automated testing that's going to burn our AWS account and hit every single service. But the ones we've tried just work because we're just transforming data, and the data is provided by AWS, and we have some faith that that's the case. So we do want your feedback. We want people to try out the different things and let us know when they don't work. Please let us know when they do work too. And you know, we'll have to make decisions if we have enough information from the data that we're getting from AWS, we'll fix whatever bug is there, and if we don't, then we may have to make some decisions to special case things, and I hope that never happens. So you can go up to GitHub if you can get access to the internet, and you can see the repo for the API. There's documentation up there. The jars are all in Maven Central. So there's the API jar, there's the endpoints jar, and then there's all the services. And you could go search for, I think, yeah, it's in the name here, Cognitect AWS/API. We want your feedback. We want to communicate for now just through GitHub issues, just so that it's all in one place. Like some of the other, oh, I just got the thumbs up. It is live. You can go to the website. I got another thumbs up from the audience. We're using this for internal projects, and so on our labs projects like this, we don't take any PRs, but we will gladly take your recommendations in the issues about how we might be able to fix a problem. And that's it. I've got like a few minutes for questions, so are there any questions?
Does it work with Clojure script?
No, not yet. And when I say not yet, that's not a promise that it will. But there are a few reasons that it can't do that yet. But you know, if that becomes a priority, it's not that big a stretch to get there. Any other questions? Yeah.
Is there a coordinate for all the services?
There's not. So in the doc directory in the GitHub repo, there's a page that today lists all of the services and the versions, the latest versions. I didn't talk about versioning. I'm not going to talk about it right now, but it's explained. Go read that thing because it's a mess that we did not make. But we could generate something that would do that. I don't know that we'll make like a jar that has them all in it, but it would be certainly easy enough to just generate another page in the documents that just has a deps, like for deps.eden that has them all in it, and you can go get that. And that might be useful if you want to start figuring out all the things that are there, so that's great. Anybody else? Just in the back. Yeah, we're not doing anything special about that. You in the back. It's yeah. What's the license? It's on the website. It's Apache. It's an Apache license. What other questions? Oh, version 2. Yeah, you all the way in the back there. The question was, since it doesn't work anyway when there's no internet available, why not just in real time go fetch these descriptions? I mean, because if we go fetch them from GitHub, if GitHub's down that minute, we've got that problem, right? So it just introduces a whole different class of problems. And also, we are doing a fair amount of manipulation to generate the Clojure specs, and that takes time. So we're doing that all up front. You in the middle. Yeah, you should certainly be able to do it. And I think this is a little bit of a red herring. I just wasn't going to take the time now to figure out why I wasn't getting. All I was doing was trying to look at some data, and apparently didn't have it on the web. Where's your striped shirt?
I don't have a striped shirt, but I do have an internet connection, and I have it running if you want to show it.
Well, okay.
No, yeah, no, you can't see it. We're just going to look up here.
I'll just read. I'm going to read to you what I see.
It's really super cool. Super cool. Here, just unplug and. Was there a particular one of the examples you were going to do?
Yeah.
Yes, I'm happy to go and.
Do you have a REPL?
I have a REPL.
Do you have a REPL?
I don't have a connector that works like this. Where's the?
Do you have one that works like this?
Hold on. Where's the kind of connector that works like that? Where's the? It's up here. The HDMI. Oh, it's on the end of that. Dole.
Ladies and gentlemen, the comedy stylings of Stuart Holloway. We're doing this in Rebel, though, right?
We're doing this in Rebel, so.
Okay.
So yeah, so I have already actually, just making sure that it worked. So this is viewing the ops data for a call. You can.
Right. So how do I do that? I want to back up the things that you called. I thought,
Yeah, no, I didn't type them in. I did them from the Rebel.
No, okay. Yeah, but you put them there eventually. So this last call was to this thing, ops data, which actually that's now just ops. And when you look at that, you could see on the right there's a map of some keys, and we could go look at any one of those. You don't happen to, well, here, do you have DDB on your path?
I do not probably have DDB on my path.
Okay. That's fine. And then you could go look at any one of these, and these are all the, what are we?
Yeah, you're looking at the.
Yep, okay. Oh.
Here, let me.
It's because his caps lock is caps lock. All right.
So let me just talk to you for a second. My A key is A. my B key is B.
All right.
You talk and I'll nav.
Okay, fine.
Say stuff and I'll try to make it happen.
All right. Actually,
I mean, I have a bunch of other.
no, go back to the REPL. That's fine. So a couple of things about the documentation. So if you scroll down to response, and you can see that this one it says pagination token string. Of course, we're not doing pagination, so whatever. But this is there's tag keys, which is a seek of strings. So you're going to see this in the request documentation, how to build it, and that should be perfectly clear. But we did that for a reason, which is that we want to be able to navigate into these things and use them in a programmatic way. Yeah, we don't have okay, yeah, that was one thing that I wanted to show, and this isn't the beautiful, beautiful example, but you could see the HTML presented as HTML because Rebel knows it's HTML and does that for you. What else would be interesting here?
Well, and so just as a tease, this little, which is not in the code yet, but this little 7-line thing with next token nav applies nav to the hand-over-hand on pagination. So once you do something like that, you can grab an AWS API, get back the first 100 results, and keep going. So eventually,
we will have pagination.
We'll have something like that.
And there's another thing that we've talked about, which is that you can imagine you called list tables in DynamoDB, and one of the data bits that you get back is an ARN, and we can look at that string and datafy ARNs so that they then go call describe table and give you all that information without you having to do anything. So there's a lot of potential here that has yet to be realized, but all the bits are there to be able to do it. So.
Yeah, and I've been working on this from a specific use case, which is, and this is just like a REPL experiments file, but this parse logs JSON. The game I want to be able to play is something happens in Datomic that I'm trying to understand. I can view the logs here as data, paginate through them, and then when the logs talk about an AWS resource, datafy and nav through it and jump straight to describing that resource and then go back and forth in the log. So I'm trying to optimize a workflow around troubleshooting, things that are going on. And it's very close, right? This combination of things is very close to being in the end zone for that.
All right. I mean, we've already
Yeah, we're past time.
shown the bits that I wanted to show, and we're past time. So thank you all very much.